Have you ever seen ice that doesn't melt into water? It's a fascinating phenomenon that leaves many people puzzled. Unlike regular ice, which turns into liquid water as it warms up, this special kind of ice seems to defy the laws of nature. It just vanishes into thin air. This is because dry ice is actually solid carbon dioxide. When it warms up, it doesn't melt into a liquid but instead sublimates directly into a gas. This process is both mesmerizing and mysterious. That's dry ice. It's super cool literally, and it's used for all sorts of amazing things. From creating fog effects in movies to preserving food during shipping, dry ice has a wide range of applications. It's also a favorite in science experiments and educational demonstrations because of its unique properties. But hold on, science fans. Dry ice can also be dangerous if you don't know how to handle it properly. Its extremely cold temperature can cause severe frostbite if it comes into contact with your skin. That's why it's crucial to always use protective gloves and follow safety guidelines. Let's dive in and learn why this amazing substance needs to be treated with respect. Understanding the science behind dry ice and knowing how to handle it safely can prevent accidents and make your experiments both fun and educational. Remember, safety always comes first in the exciting world of science. Whether you're a budding scientist or just curious about the wonders of dry ice, always prioritize safety to ensure a positive and enlightening experience. Dry ice isn't your ordinary ice made from frozen water. It's a fascinating substance with unique properties that make it incredibly useful in various fields. Nope. This cool customer is actually solid carbon dioxide, the same gas we breathe out. When carbon dioxide gas is cooled and pressurized, it transforms into this solid form. It's made by cooling and compressing carbon dioxide gas until it turns directly into a solid. This process is known as sublimation, where a substance transitions from a gas to a solid without becoming a liquid first. Dry ice is way colder than regular ice, about minus 78.5 degrees Celsius, or minus 109.3 degrees Fahrenheit. This extreme cold makes it perfect for preserving perishable items and creating dramatic fog effects in entertainment. That's why it doesn't melt into a puddle but turns directly back into a gas. This process of sublimation is what gives dry ice its name and makes it so unique. When exposed to warmer temperatures, it skips the liquid phase entirely, creating that iconic smoky effect. Dry ice is used in a variety of applications, from keeping food fresh during shipping to creating special effects in movies and theater. Its ability to maintain extremely low temperatures without leaving any residue makes it invaluable in many industries. However, handling dry ice requires caution. Because of its extreme cold, it can cause severe frostbite if touched with bare skin. Always use protective gloves and proper storage methods to ensure safety. In educational settings, dry ice is often used to demonstrate scientific principles such as sublimation and the properties of gases. Its dramatic visual effects make it a favorite for science demonstrations and experiments. From everyday uses to industrial applications, dry ice continues to be an essential tool. Its versatility and unique properties ensure that it remains colder than your freezer and a staple in many fields. Dry ice is used for all sorts of cool things. Since it's so cold, it's great for keeping things frozen. You'll find it used to ship food and medicine that needs to stay super cold. Dry ice also creates those spooky fog effects at Halloween parties and rock concerts. When it warms up, it doesn't make things wet like regular ice, so it's perfect for special effects. Section 4. Danger Zone. Dry ice risks and how to avoid them. Dry ice, while incredibly useful in various scientific and industrial applications, poses significant risks if not handled properly. Here's where we have to be extra careful. Understanding the potential hazards associated with dry ice is crucial for ensuring safety in any environment where it is used. Dry ice is so cold, it can cause severe burns if it touches your skin. The temperature of dry ice is around minus 78.5 degrees Celsius, which is cold enough to cause frostbite almost instantly. That's why you should never touch dry ice with your bare hands. Even a brief contact can result in painful injuries. Always use gloves and tongs to handle it. Thick, insulated gloves provide a barrier between your skin and the extreme cold, while tongs allow you to move the dry ice without direct contact. Another danger is that dry ice turns into carbon dioxide gas as it warms up. This process, known as sublimation, can quickly fill a space with CO2. In a closed space, too much carbon dioxide can displace oxygen, making it hard to breathe. High concentrations of CO2 can lead to dizziness, headaches, and even suffocation. Always use dry ice in a well-ventilated area. Proper ventilation ensures that any carbon dioxide gas produced can disperse safely, reducing the risk of CO2 buildup. By following these safety guidelines, you can effectively minimize the risks associated with dry ice and use it safely in your projects. Section 5. Respect the ice, staying safe with dry ice. Remember, science fans, safety first. Never play with dry ice or leave it unattended around children or pets. If you are using dry ice, make sure adults know how to handle it safely. By following these simple safety rules, we can enjoy the wonders of dry ice while staying safe. Remember, knowledge is power, and knowing how to handle dry ice properly keeps the cool science coming.